Okay, we're going to look at the second day of trigonometry. And this is more, we're looking at the inverse of the trigonometric functions. So definitely you'll need a calculator for this one too, or find some kind of online thing that will help you. And I'll show this to you in just a second. But this is inverse trigonometric ratios. So what happens is if the sine of some angle A equals x, then what we can do is we can say, so we don't know this measure, but we do know what it's equal to. So we have an actual value in that spot. Then we can say, we'll take the inverse sine, which looks like that, sine to the -1, the power of -1 of x. So we're saying the inverse of this sine using the number that you've got, and that will be equal to the measure of angle A. So this value that you don't have, you can find it by using this. And this is actually a button on the calculator. So it's not hard to find it once you've figured out what you're looking for. Works with cosine too. We can say the inverse of cosine of, inverse cosine of, and then we'll put whatever value that is that we know it's equal to, and that will give us the measure of that angle. Also works with tangent, so we can say the inverse tangent of, and then you put that value that you've got in, equals the measure of angle A. So this is an awesome way to solve for a missing angle. Here's one we can look at. If the tangent of 30 degrees equals 58.58, then we're going to do tangent to the -1, the inverse tangent of 0.58. So we took that value, is equal to the measure of angle, this angle, which is 30. The measure of that angle is 30 degrees. Okay, and let me show you where these buttons are on the calculator. And I think yesterday we talked about making sure that we had our mode in degrees. So I want to repeat that. If you're using a TI-84, there's this mode button where you go in and you do make sure that you're in degrees, because we don't want to come back with radians right now. We're not working on that yet. Okay, so let's try this one. The inverse tangent of 58. So on my calculator, that's the tangent button. And right above it in blue, you'll see it says tangent to the -1. That's the actual thing I want to use, the inverse of tangent. So I need to push my second button and then tangent. And what pops up is the inverse tangent. It's perfect. Let's put this in 0.58 and see if it comes out to be 30 degrees. Okay, and there's some rounding that went on here, but that is it. So that's how we're going to solve for these missing angles. Really similar process to what we did with the missing sides in the first part of this chapter. So we want to label the sides adjacent, opposite, and hypotenuse, so we know what's what. Then identify the trig ratio that would go with that. And maybe we should just write here so we don't forget. So, ka, toa. So you know what pieces go with the different trig functions. Set up an equation. We did that yesterday. And then we're going to use that inverse trig ratio to solve for x. Let's try one together. So we've got this triangle, and let's go ahead and say, it doesn't actually say, but we're going to go ahead and say we're solving for r. We want to know what the measure of this angle r is. Okay, so if that's our angle, this is the hypotenuse. That part doesn't change. What's 29? Is that the opposite side, or is that the adjacent side to this measure, to this angle r? Adjacent, yeah, it's right next to it, like right next door. Your adjacent neighbor is right next door. Okay, so if we've got adjacent and hypotenuse, which one of these trig functions are we working with? It's that one right there. Adjacent and hypotenuse goes with cosine. So I'm going to write this out. The cosine of angle R would equal adjacent over hypotenuse. And then we're going to put in the pieces that we know. Cosine of R equals 29 over 34. Okay, so we know what it's equal to, but we want to know what this actual number is. What's that angle? This is where we start doing the inverse. So let's write the inverse of that cosine. And we take that value from the other side. We know what it's equal to, and we're doing inverse. It's like we're undoing it. 29 over 34 equals the measure of angle R. So we just like flipped this thing inside out. We said, okay, we've got this part. Let's work backwards through the cosine. Let's do the inverse with that piece, and then we'll find out what that angle is. This we just type in our calculator. So I'm going to grab my calculator. And I need to do second cosine to get that to open up as the inverse. And then 29 divided by 34. So I put my fraction in there, enter, and now I can see that that angle is 31. And I think we'll still use, well, let's do tenths. I think it does say that on here somewhere. Yeah, we'll go to tenths. So we're going to go one place after the decimal. It's 31.5. 31.5 degrees equals the measure of angle R. Okay, so that's how we're going to work with our inverse tangent, cosine, sine to find missing angles. Let's do one more together and then we'll let you try. This says use a calculator to find the measure of angle L to the nearest tenth. So here's L. This is the one we want to find. We have a hypotenuse and we have an opposite. We don't have adjacent. So let's see which trig ratio works with opposite and hypotenuse. That would be sine. Yeah. Sine of L equals opposite over hypotenuse. And we've got those two numbers to fill in. So the sine of L is opposite 32, hypotenuse is 40. Okay, and what we're solving for is this number right here, this angle measure, which we don't have. So we're going to work backwards. We're going to say, well, then the inverse, if we take the inverse function and put in the answer to the original, then we'll get the measure of angle L. And at that point, we just grab our calculator. Second sine, so it pops up as the inverse sine 32 divided by 40 is 53.1, and we're going to tenths, so 53.1 is the measure of angle L. Done. Okay, all right, I got two for you to try. Take a few minutes, this will take a few minutes, and label those sides, figure out which trig ratio is the best, and then set up an equation and solve for that missing angle. It says for both of them to look for T. So you'll be doing T and T on each one. All right, pause that and try it out. Okay, let's see. Here's angle T. We've got a hypotenuse, and we've got an adjacent. That sounds like a cosine, right? Cosine of T equals adjacent over hypotenuse, which is 32 over 101. Woo. Now we've got to do the inverse since we really have the answer to this. Let's undo it. Measure of angle T. Second cosine of 32 divided by 101. Did you get 71.5 degrees? Angle T. Awesome. All right, let's try this last one then. So it's angle T we're looking for. We have a hypotenuse and we have an opposite. That sounds like sine, right? The sine of T equals 7 over 18. So let's do the inverse to find the measure, of T, angle T. Oops, I did cosine. Sine of 7 divided by 18 is 22 point, and if I'm rounding that to the nearest 10th, 9 degrees equals the measure of angle T. Okay, hopefully you got that. Yes, way to go. Let's turn this over then. All right, the last thing we're going to look at is solving to solve a right triangle. Solve a right triangle. What that means is you find all 3 angle measures and all 3 side lengths. That would be a solved right triangle. So there's no pieces are missing anywhere. And what we'll do is we've got a triangle here, right? It's a right triangle. So I know this angle B is 90 degrees. Generally, they have to give you that. If it's not a right triangle, then none of this is going to work. And then they've given us 2 side lengths. So from B to C is 27. And from A to C or C to A is 45. We are missing 1 side and we are missing 2 angles. So what we can do to find those 2 angles, let's pick one. I'm just going to pick C. We could have picked A, but we're going to go with C first. To solve that, we'll do what we were just doing on the front. We need to label the sides. This is the hypotenuse, and this is our adjacent side. And we'll do the inverse trig function. What ratio? Which one do we need for that? If we have adjacent and hypotenuse, that sounds like a cosine of C equals adjacent over hypotenuse. So we'll do 27 over 45. And when we're solving for this, we need to do the inverse function, 27 over 45. Okay, and this is how we'll solve for angle C. I'm going to grab my calculator. Inverse cosine of 27 divided by 45 is 53.1. 53.1 degrees equals the measure of angle C. I'm going to put a little box around this so that as I do the different pieces, I can keep separated in my mind what's what. So the measure of angle C, 53.1 degrees. Now for the third angle, we know that there are 180 degrees in a triangle. If you subtract out 90, that leaves 90 for the other 2. So let's do 180 minus 90, 90 left. And let's take out the measure of angle C, 53.1. That means that last angle, and I'm just gonna write it here so that you've got that on your paper later when you're looking. 180 minus 90 minus 53.1 equals 36.9. So then when you look back later, you can say, oh, that's how we found that third angle, 36.9. And if we had decided to find angle A first, which would have been fine, it doesn't matter. Then we could do some subtraction and we could have found the measure of angle C that way. Okay, the last thing we need is this missing side. So you've got options there. You could use one of the trig functions. You could do the Pythagorean Theorem, which is what I'm planning to do. And I need to figure out which side is the hypotenuse. That's this one. So this would be C in the Pythagorean Theorem. A squared plus B squared equals C squared. I'm going to put the 45 right there. And then I've got one of these two, 27 squared. And I don't know that one. So let's go ahead and solve for that last side. 27 squared is 729 plus b squared equals 45 squared, 2025. We'll move this to the other side. We're trying to solve for b, right? B squared, 1,296. Okay, so b squared is 1,296, but I just want plain old b. Take the square root of both sides. Square root of. And oh, it's a nice whole number, 36. Love that. Okay. So that was our Pythagorean to find that third side, which we now know is 36. That is the solution. We just solved that triangle. So several steps you might have to go through to get that done. Let's do one more together, and then we'll give you a chance to try some on your own. All right, so this triangle is tall and skinny. We have angle Y is 90 degrees. Put that one in. We don't have the other two angles. And then we've got two sides. X to Y is 35. And then Y to Z is 12. And we're missing Z to X. So you could even do the Pythagorean theorem first if you wanted to and find that last side. It doesn't matter what order you go in. We'll shake it up. We'll do that. So this side is the piece that's missing. I'm going to mark that C. I have an A. This can be my A and this can be my B. So 12 squared plus 35 squared equals that missing piece squared. 144 plus 35 squared is 1,225. And if I put them together, 1,369. So we need to then take the square root of both sides. Oops, that's not the right one. Square root. Oh, I love that it's a nice number for us, huh? Okay, so the third side, ZX, is 37. I'm going to put a box around that, keep that separate. That is 37. And now I actually have all three sides of the triangle. Now you got to pick, do you want to work on angle X or angle Z first? Let's do angle X. So we'll go from this perspective. This is the hypotenuse, 37. This would be our adjacent. And then this guy is our opposite. So we could pick any trig function we want. We've got all three pieces. What have we not done in a while? How about a tangent? You want to try a tangent? Okay, so I'm going to say the tangent of X is, now it would be opposite over adjacent. And we know that opposite is 12. Adjacent is 35. That's what we're solving though. So we need to do the inverse tangent. Since we have the answer to that is 12 over 35. That will give us that measure of angle X. So let's try second tangent of 12 divided by 35. That is 18.9 degrees is the measure of angle X. 18.9 degrees. Put that up here. 18.9. So now we just have that one angle left. And what we can do is say it's 180 degrees altogether for a triangle. Subtract the 90, subtract the 18.9, and that leaves 71.1 for that third angle. And we just solved another triangle. Okay. All right, I've got two for you to try. Let's have you go ahead and pause your video, try the first one, and then we'll come back and we'll go over it and just make sure if you have any questions, and then we'll pause again and let you try that last one. So take a second for this first one. All right, let's see. Angle Y is the 90-degree one. And XY is 40. YZ is 30. This is the side we don't know. That's the hypotenuse, right? So, man, there are tons of different ways you might have taken to do this. You might have said, I'm going to solve for Z. And in that case, you had opposite over adjacent. I'll take that way. We will get the same answers even if you went with, maybe you went with X, or maybe you did the Pythagorean first. We should end up with the same answers. So opposite, so I'm doing tangent of Z equals opposite over adjacent. And I need to do inverse of that to find the actual measure of the angle, 40 over 30. Let's see, inverse 40 divided by 30. So I've got 53.1 degrees for angle Z. Check and see if that's what you got for angle Z. 53.1. Then to find angle X, 180 minus 90 minus 53.1. 0.1, 36.9 for angle X. So we just need to figure out that third side now. And it's the hypotenuse side. So A squared will do 40, B squared will be 30, and this is the piece I'm looking for, the hypotenuse. 1600, 900. 2500 equals C squared. We have to take the square root. Square root looks like 500, no, 50, sorry. 50 equals C for that last side. Done. Okay, I want you to go ahead and pause your video and try that very last one, and then we will check that one as well. All right, let's do it. Angle B is the 90, and side AC is 29, side BC is 20. So I think I'm going to do the Pythagorean first this time. This is the hypotenuse, so that's like our C. This can be A or B, doesn't matter. Okay, A squared, I'll do 20 squared plus something unknown equals C squared. And you know what? I should make that a B. So it's like A squared plus B squared. That's probably a better idea. 20 squared is 400. Don't know that one. And I didn't even put a number in for C squared. We know it's 29. Let's see, 29 squared. 841. So let's subtract this, B squared equals 441. Oops. All good. It's another whole number. So square root, square root. Did you get 21 for that last side? Good. And remember, we did look at Pythagorean triples. Some of these you might find. I know this is times 10 of one of our Pythagorean triples. So that might help you with some of these too, if you can look back at those. All right, that's our third side. Now I know this is actually 21. Now we pick, do we want to work on A or C? I'm gonna pick, I'll just pick A. All right, and let's see, adjacent, opposite. I think I'll just do cosine. Cosine of A is adjacent over hypotenuse. All right, and you might have picked a different one. That's okay. Our answers should come out to be the same if we both do it right. That's the measure of angle A. Inverse cosine is 43.6, measure of angle A. 43.06. And then our last angle, how can we find that? How about 180 minus the 90 minus 43.6? Did you get 46.4? It's really close to being a 45, 45, 90 triangle, but not quite. Okay, that is the end of what we're going to learn about trig for right now. You do have an assignment so you can practice finding missing angles. You're going to need that, be able to do that inverse angle or inverse function for that, and then solving triangles. Okay, good luck.